we're going to look at one example of taking a polynomial function and writing it in different ways. So we want to be able to write our polynomial as a product of factors that are irreducible over the rationals. We want to be able to write our polynomial as a product of linear and quadratic factors that are irreducible over the reals. And then we also want to be able to write our polynomial in completely factored form. And I apologize for whatever is going on in my living room right now that you may be hearing in the background. So we are going to look at the polynomial function f of x equals x to the fourth minus 2x cubed minus 3x squared plus 12x minus 18. And I'm even giving you the hint here that one of the factors of this is x squared minus 6. So since we know one of the factors of this, we could divide this polynomial by that factor. Now x squared minus 6, it's not in the form x minus a number, so we can't use synthetic division, unfortunately. We're going to have to use long division. But we know we're dividing by x squared minus 6, so that goes outside our division box. Inside our division box, we'll have our polynomial function that we're dividing up. We want to make sure that we have a place value for every power of x greater than the degree of our function. So we have x to the fourth power minus 2x cubed minus 3x squared plus 12x to the first minus 18. We have all our places taken care of there. We can do our little cheat, look at our first terms. What can we multiply x squared by to make it look like x to the fourth? Well, that would just be x squared. So we put that in our x squared column. We take our x squared, we distribute it to everything in our divisor. So x squared times x squared is x to the fourth. X squared times negative 6 would be negative 6x squared. We're subtracting the numbers in this row from the row above, so we're going to change the signs on those. And then we add within our columns. So here we have x to the fourth minus x to the fourth adds up to 0. That's what we want to happen. The negative 2x cubed, we don't have anything to combine with, so we just bring it down, negative 2x cubed. Negative 3x squared plus 6x squared would give us a positive 3x squared. The 12x and the negative 18 we haven't done anything with, so we just drop those down as well. And then we do the same thing. We look at only the first term in this row. Can we make x squared look like negative 2x cubed? Absolutely we can. We need to multiply by negative 2x. So then we'll take that negative 2x and distribute it to everything in our divisor. Negative 2x times x squared gives us negative 2x cubed. Negative 2x times negative 6 gives us positive 12x. But we're really subtracting everything in this row from the row above, so we need to change the signs of everything in this row. So this is going to become a positive, this is going to become a negative, and then we can add within our columns. So here we will have negative 2x cubed plus 2x cubed adds up to 0, cancels out. That's what we want. Our 3x squared we haven't done anything with, we don't have anything to combine it with, so we just drop it down. 12x minus 12x adds up to 0, so I'm going to put in that placeholder of 0x since I'm not done dividing. And then my negative 18 I haven't done anything with, so it still just comes straight down. I do the same thing again, look at the first term here and the first term in my divisor. To make x squared look like 3x squared, I just need to multiply by a positive 3. I'm going to take that positive 3 and distribute it to everything in my divisor. 3 times x squared is 3x squared. 3 times negative 6 would be negative 18. But I'm subtracting everything in this row from the row above, so I need to change the signs on those terms. And then I can add within my columns. So here 3x squared and 3x squared adds up to 0. My 0x is already 0, doesn't matter, don't need to bring it down. Negative 18 and positive 18 also adds up to 0, so I have a remainder of 0. So here we can see that this does indeed divide evenly. X squared minus 6 is a factor of our polynomial. So we could rewrite our polynomial. We could say that this is f of x equals that factor that we divided by, x squared minus 6, times what we have left over, is x squared minus 2x plus 3. Let me just copy this and put it on the next page for us here. So this is what our function looks like. Now eventually we want this to be fully factored, so we may as well just fully factor it now. So if I take that factor of x squared minus 6 and set it equal to 0, I know that I could say that this is x squared equals positive 6 by adding 6 to both sides of my equation. When I take the square root, I'll get x equals plus or minus the square root of 6. Now, can I take the square root of 6? No, that's not a perfect square. Yes, I can take the square root, it just doesn't give me a nice pretty whole number. It gives me an irrational number. So these zeros are real numbers, but they're not rational. If we look at our other quadratic here, we have x squared minus 2x plus 3. That is not one that factors nicely. There's nothing here that would multiply to give us 3 that adds up to negative 2. So I'm going to have to use a quadratic formula on that one. So here on that, I'd have my a value is 1, my b value is negative 2, my c value is 3. My quadratic formula, x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. When I plug in my numbers in the right places, this is going to become negative 2 plus or minus the square root of negative 2 squared minus 4 times 1 times 3 all over 2 times 1. If I simplify this, it's going to become x equals 2 plus or minus the square root of negative 2 squared would be positive 4. Negative 4 times 1 is negative 4, times 3 is negative 12, all over 2 times 1, which is 2. Simplify further underneath that radical. So we have x equals 2 plus or minus the square root of negative 8 over 2. A negative means that I have an imaginary number involved. If I simplify the square root of 8, I have 2 root 2. So this is x equals 2 plus or minus 2 root 2 I over 2. I know that I can break this up into the real number piece and the imaginary number piece. So I have 2 over 2 plus or minus 2 root 2 over 2 I. So we could really say that this is x equals 1 plus or minus root 2i. Obviously, these are not real number zeros because we have an imaginary number. And if they're not real numbers, that means they're also not rational. So here, if I look at my function, the degree of the function that we started out with, it was a 4th degree polynomial. I have 2 zeros from this quadratic, and I have 2 zeros from this quadratic. So I have 4 zeros altogether. That's the degree of our function, so these are all of the zeros of our function. So if we look at what we wanted to do, the different ways that we wanted to write this function, the first way we wanted to write it was as a product of factors that are irreducible over the rationals. So remember, irreducible over the rationals means that we can factor them into linear factors that are real numbers, but just are irrational. Well, here we have some real numbers, but they're irrational, so we can use these as linear factors. These were not real numbers, so these we cannot use as linear factors. So for that first way of writing our function, part A here, we're going to write our function f of x these numbers, root 6 and negative root 6, we're going to write as linear factors because they are real, they're just not rational. So we can say we have x plus root 6 and x minus root 6. These two zeros are not real numbers, so we're not going to write them as linear factors. We're going to leave them as the quadratic that we got those zeros from. So we're just going to leave that quadratic x squared minus 2x plus 3. So that gives us our polynomial as a product of factors that are irreducible over the rationals. For part B, we want to write our polynomial as the product of both linear and quadratic factors that are irreducible over the reals. So remember, irreducible over the reals means that we're going to have, I mixed that up. Sorry, what I just wrote are the factors that are irreducible over the reals. So this should be part B. Sometimes we all make mistakes. It's okay. And these definitions are a little hard to understand, and if you're not paying full attention, then as you can see, things happen. So these are the irreducible over the reals. So we can reduce them. And here when we reduce, we have real numbers. They're just irrational. Here we cannot reduce to get real numbers. For part A, that I got this mixed up with, we wanted factors that are irreducible over the rationals. So when we reduce them, we don't get rational terms. So here, these are not rational numbers. These are not rational numbers. So we're just going to leave it as the quadratics. So here for part A, we actually already wrote that when we factored the x squared minus 6 out of our function. So this should really just be x squared minus 6 times that other quadratic x squared minus 2x plus 3. There we go. So here, this is how we write it, where we have factors that are irreducible over the rationals. If I break this down into linear terms, those linear terms are not rationals. If I break this down into linear terms, those linear terms are not rationals. So we leave it like this. These are irreducible. When we reduce, they will not give us rationals. Part B here, these are linear and quadratic factors that are irreducible over the reals. I can reduce these to linear terms. They are real numbers. I cannot reduce our quadratic into linear terms because I would not get real numbers. Part C, we want to know the completely factored form. So if we take and we break it down into all of the zeros of our function, writing them as factors, what does it look like? So we should have 4 factors since we had 4 as the degree of our function. So we know we have x plus root 6 and x minus root 6. And then if we take our other 2 zeros, 1 plus root 2i and 1 minus root 2i, we'll have x minus that 0, 1 plus root 2i, and x minus our other 0, 1 minus root 2i. So you could leave it like this, or these zeros here, you might want to distribute the negative. Totally up to you. I would accept it either way. So if you wanted to write this as x plus root 6, x minus root 6, x minus 1 minus root 2i, and x minus 1 plus root 2i. Either way is okay here. If we write it this way, we can see the x minus 1 part is exactly the same. That's the real number portion. The root 2i and the negative root 2i part is exactly the same. Only one is positive and one is negative. So these are conjugates with our imaginary numbers.